Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about explaining exception handling in Java. So, whether you're developing a complex program or a complex application, errors, they're inevitable. They're always going to happen in your code for some reason. That's where exception handling comes in. In this video, we'll learn how Java's exception handling mechanism helps create error-tolerant programs by handling unexpected situations. First, let's talk about what even are exceptions. So, an exception is an event that disrupts the normal flow of a program. Examples include dividing by zero, accessing an invalid array index, or trying to open a file that doesn't exist. Because of these common errors in code, Java provides a built-in mechanism to detect and handle these situations so that your program can recover or exit gracefully. Next, let's talk about some technical details of exceptions. So, exceptions in Java are part of the throwable class hierarchy. In this throwable class hierarchy, there are two main branches: errors. Errors represent critical problems like running out of memory. These are usually beyond your control, and they should not be handled in your program. The other main branch are exceptions, which we're going to talk about today. These represent issues that you can anticipate and handle, such as an invalid user input or file accessing errors. Now let's move on to handling exceptions with some code. So I'll just code this and explain it. First, I'll import this just in case we need to use it. Alright. My class name is going to be main because the class name has to match the file name. For exceptions, we don't need to create like a separate class or anything, so I'll just go straight with the main method. So our main method is public static void main string and args. Alright, so first I'm just gonna code this and explain it. So try. So let's say we define a number, right? So let's say int n equals 10 over 0. Well, this is obviously an error, so this part throws an exception, right? And then we can also use the catch the catch keyword. So for this, we catch an arithmetic exception that we can call e. So arithmetic exception e. Alright, so for this, we can actually just like print out the number. So we can use IntelliJ's built-in shortcut system.out.println, and we can just like take n, so we can print n, right? So then we catch an arithmetic exception e, and then our error message is going to be using the built-in shortcut for system.out.println. We can do error division by 0 is not allowed. And then after this, we can just print out program continues just to signify that it will continue. Alright, sorry about that. Alright, so in this example, we are dividing a number by 0 as shown here. Oh, sorry, I didn't add a semicolon, sorry. So in this example, we are dividing a number by 0, which triggers an arithmetic exception, which we call e. So in this case, the try block contains the code that may throw an exception, while the catch block captures, which is why it's called catch, and it handles the expression, which prevents a crash by happening. When an exception occurs, the rest of the try block is skipped and control jumps to the catch block. So if we run this, right? it prints out error division by 0 is not allowed. Program will continue shortly because division by 0 is classified as an arithmetic exception. Next, let's move on to talking about multiple catch blocks, right? So I'll just code this real quickly. Sorry. Array out of index bounds exception. Now we have, we print out our error message, which is error accessed index is out of bounds. And then our final catch is just like a normal exception, exception E, which is just alright. Now let's explain this code. So Java allows you to use multiple catch blocks to handle different types of exceptions, right? So in the order that you're using your catch blocks, the most specific exception should come first. Like let's say like your arithmetic exception, or so it's in order from most specific to least specific, right? So we have arithmetic exception, array index out of bounds exception, and just like a general exception, right? Sorry, I have to define a name for this. It's called E, right? So let's say we have something like this, right? So let's say we print out the fifth element in our array, the one with the fifth index. But wait, there is no fifth index. If we run this, we have access index is out of bounds. So next, let's move on to see if our arithmetic exception works, right? So we can just have array of 1 over 0. Now we have arithmetic error has occurred. So next, let's just do like a general exception. Like, actually, I think, yeah, no, we don't have to do that. Alright, so to summarize multiple catch blocks, the least general, like the most specific exceptions are handled first, and then they're handled in order of like generalization. So the least specific ones are handled last. So this ensures that exceptions are handled properly and in the right order. So let's move on to another example. Alright, so sometimes you need to execute code regardless of whether an exception occurred. This is where we use the finally block. So let's see an example of this. So first we have our normal try, and let's just use our same example from before. Int n equals 10, like 5 over 0, right? So, and let's try printing out n, and let's try printing out to n. Using IntelliJ's built-in shortcut, print out n, right? And our catches are that we have an arithmetic exception, let's call it E. And then our error message would be that using IntelliJ's built-in shortcut, we can just have an arithmetic error has occurred. right? And we can add a finally block. So finally system sys f out, right? IntelliJ built-in shortcut. So this this executes no matter if there's any exception or not. So I'll just print out this line executes, always executes, right? Executes, right? All right. So let's talk about how you can manually throw exceptions. So using a keyword called throw, you can also throw exceptions manually. So here's an example. So let's say I have my age, right? So let's say my age is 13, right? Right? And let's say I want to throw an exception if my age is less than 13, right? So, not a for loop. If age less than 13, so we throw a new, let's just say, let's just have an illegal argument, right? Because our argument doesn't work. Let's have an illegal argument exception, and our error message would be that you are not old enough, right? So after this, we can just print out. So if this doesn't happen, we can just print out just f out access granted. So let's see if this works, right? We print out access granted because 13 is not less than or equal to 13. But let's say my age is like 12, right? We print out, we've manually found our error. It says, you are not old enough. So, in conclusion, here are the key points about exception handling. So, we can use try-catch blocks to handle exceptions generally. We can use finally for like cleanup tasks regardless of exceptions. And we can use throw to manually erase exceptions. Exception handling is essential for writing code with Java. Thank you guys for watching the Super 7 programming tutorial. See you in the next one.